Hello.
No.
Yeah. We'll continue with questions. Uh, this is the first one. Find the value of this limit. Here you should know that this x power n by e power x is coming everywhere, right?
No.
And if you think this e power x can be brought down, it's the x power n by e power x here. So limit of n tends to infinity of this. So you should first think about what is limit of x tends n tends to infinity x power n by e power x. Actually, it is x tends to infinity, not n tends to infinity, right? X.
No.
So this you can figure out from the graph, and you need to know that e power x will rise above any x power n curve, no matter what n is. E power x eventually is large, grows faster because here x is in the power, right?
No.
Any x power n that you have, e power x will go above it. Maybe in the beginning it might be above, but later e power x will rise above. So if you realize that limit x tends to infinity, x power n by e power x tends to 0. How can we convince ourselves that this is true? We can do L'Hospitals, right? This is infinity by infinity, right?
Right.
This is infinity by infinity form. So if you do L'Hospitals, you'll get nx n minus 1 by e power x. Notice that e power x didn't change, right? This is still infinity by infinity.
Yes.
So if you keep doing it n times, the top will become a constant, right? N
Right.
factorial or something. And denominator is still e power x, right?
Right.
Correct. So now at this stage, it is no longer is infinity by infinity. It is constant by infinity, which is 0, right?
Right.
Are you convinced that this tends to 0?
Yes.
Because if that tends to 0, then we can take a substitution. Your t can become x power n by e power x. You can say limit x tends to infinity, x power n by e power x tends to 0. So therefore, this whole thing can be changed and it becomes limit t tends to 0. You have 2 power t minus 3 power t by t, right?
Right.
Now find the value of this limit.
ln2 minus ln3.
Hmm. ln2 minus ln3 will be your answer here. Are you understanding how we did this?
Yes.
So next one is this. F is an invertible function. F is an invertible function from R to R, from R to R, which satisfies the equation f cube x minus x cube plus 2 f square x plus 2x cube plus 1 f of x minus x cube is equal to 0. And you have to find the value of f dash 8 multiplied by f inverse dash 8. So you need to understand that this is f of x whole cube, okay? This is f of x whole square, this is f of x. And this is derivative of the inverse at 8, and this is derivative at 8. Right?
Right.
You have to simplify this a little bit. You should be able to factorize it. See this and this and this, right? You can take f of x common, it will become f of x square minus 2 f of x plus 1, right?
Right.
And in this and this and this, you take x cube common. You'll get f of x square minus 2 f of x plus 1, right? Correct.
Yes.
You're getting f of x minus 1 whole square common and f of x minus x cube. So either f of x is 1 or f of x is x cube, right?
Right.
So now you can, if f of x is x cube, you can easily find everything now. F dash x is 3x squared, so 3 into 8 square. And if f of x is x cube, your inverse would be x power 1 by 3, right?
Right.
X power 1 by 3 inverses derivative will be 1 by 3 x power minus 2 by 3. So 1 by 3 by x power 2 by 3. So 8 power 2 by 3. You multiply this, 3 cancels. You have 8 power 2 divide minus 2 by 3. 8 power 4 by 3, which is 2 power 4, which is 16. If f of x is 1, this whole thing will be 0.
Right.
Right? So depending on the options, you can select the answer now. Correct?
Yes.
So it was a matter of factorizing this expression. If you factorize it, you will get this, and then it is easy. The next one is this. Let x1, x2 till x10 be the roots of the polynomial equation x power 10 plus x power 9 plus so on plus x plus 1 is equal to 0. Find the value of summation n is equal to 1 to 10, 1 by 1 minus xn. Any ideas on what to do?
It's complex number, so e to the power. Yeah, that is x power 11 minus 1 equal to 1 roots. And then,
You can write it like that, x by 11 minus 1 by x minus 1, right?
right,
But does that help? Writing it like that, does it help? I don't think it does help much. So one thing here, you know, that if there are some roots of a polynomial equation, then always you can write it as x minus x1, x minus x2, and so on, right?
right,
X minus x10. This equation, this expression is equal to this. Then only x1 to x10 are the roots, right?
right,
Now here, if you could have put x is equal to 1 on both sides, and then you would have gotten the value of what? 1 minus x1 into, would have been equal to 1 plus 1 till here, right?
right,
So basically 11, right? Unfortunately, that is not what they are asking. They are asking something similar, but they are asking 1 by 1 minus xn sum. They are asking 1 by 1 minus x1 plus 1 by 1 minus x2 and so on, right?
right,
So notice that in this equation, putting x is equal to 1 gave us the 1 minus x1, 1 minus x2 terms. So what can you do to this equation so that you can get such terms? Like, first of all, the products have to be separated into sums, right? Right now, they are all multiplied together. You want to convert it to a sum, right?
right,
So then obviously log is a good way to convert that. So log of 1 plus x plus whatever till x power 10 would be equal to log of x minus x1 plus log of x minus x2 and so on, correct?
yes,
Now, once you have this, we are now close to the solution. So what can you do to take reciprocals here? Get reciprocal. Can you do something to this equation to get a reciprocal? 1 by
differentiate,
differentiate both sides. So you'll do 1 by 1 plus x plus whatever till x power 10. And on top will be 1 plus 2x, x square will become 2x, then 3x square, and so on till 10x power 9, right? Will be equal to 1 by x minus x1 plus 1 by x minus x2 and so on, right?
right,
And now if you put x is equal to 1, you will get the required expression, right?
yes,
So if you put x is equal to 1 in this one, you will get 1 plus 2 till 10. So 10 into 11 by 2 divided by 11, right?
Right.
Correct.
Yes.
So basically the idea here was if x1, x2, x10 are the roots of this, then you can write it as a product of factors x minus x1, x minus x2, and so on. Many times just writing it like that is useful enough and you can solve questions from there, because they might ask you something like what is 2 minus x1, 2 minus x2 product? Like you just put x is equal to 2 here, or something else they might ask, but many times this much is enough. But in this case it was not enough because you have to do a sum, and the sum was reciprocals of 1 minus xn and all. So you take log to separate the products into sum, and then you differentiate to get reciprocals, right?
Right.
So that is how you do this one. Then the next one is this value of, find the value of limit n tends to infinity summation r is equal to 1 to n pi by n into 1 by sine of n plus r pi by 4n. Find the value of this limit. This is definite integral as limit of a sum. You have to figure out what the integral is.
Cosec pi by 4 plus pi by 4x dx.
It should be like this: 0 to 1, 1 by sine pi by 4 x plus 1, right?
Right?
Correct.
Yes.
So now find this value. You have to find the value of this integral. You should take x plus 1 pi by 4 as t. Then the integral will become 4 pi by 2 to pi by 4 cosec t. Are you getting something like this?
Yeah.
So what is the value of cosec t integration?
And then tan t by 2.
Ln tan t by 2, and you have 4 here, and you have to evaluate this from pi by 4 to pi by 2. Your answer will come 4 ln root 2 plus 1. Okay.
Right?
Okay. Next one is this. If you have f goes from 0 to 5 to r such that f double dash x is equal to f double dash 5 minus x for all x belonging to 0 to 5. You also have f dash 0 is equal to 1 and f dash 5 is equal to 7. You have to find the value of integral 1 to 4 f dash x dx. So somehow you have to use this result somehow. Can you integrate this? What happens if you integrate this expression? Integral of this will be f dash x. What is the integral of this?
Minus f dash 5 minus f.
So you have this situation and plus some integration constant, right? When you
Yeah.
integrate, you will have some C1 and some C2 in both. So you can just place a plus C somewhere, right? Correct.
Yes.
So you have this relation which implies that f dash x plus f dash 5 minus x is equal to C, right? Correct. And what is the data given? F dash 0 is 1 and f dash 5 is 7. So you put x is equal to 0 here, you get f dash 0 plus f dash 5 is equal to C. So this is 1 plus 7, right?
Right.
So you end up getting the result that f dash x plus f dash 5 minus x is equal to 8. Correct?
Yeah.
Now let's focus on the integral here. We have I is equal to integral 1 to 4 f dash x dx. By applying the a plus b minus x property, this is also equal to 1 to 4 f dash 1 plus 4 minus x. So 5 minus x dx, right?
Right.
So 2i would be equal to integral 1 to 4 this plus this, right? Correct.
Yeah.
And that is equal to 8 as we have seen here. So 2i is equal to 1 to 4 8 dx, which becomes 8 into 3, so 24. So I is equal to 12. Do you understand?
Yes.
Basically the idea is, can we use this double derivative equation to get something like this? If you integrate it to get it like this, and can you use this data now to get a result that f dash x plus f dash 5 minus x is equal to 8? Because here you have to find integral a to be f dash x, and when you do a plus b minus x, that becomes 5 minus x. So those are special integrals that we need to find, right?
Yes.
Okay, then uh, try these two questions before the next class. I will just write a couple of questions. This is integral of 3 tan x minus pi by 4 by cos square x root over tan cube x plus tan square x plus tan x dx is equal to k tan inverse root over tan x plus 1 plus cot x plus c. You have to find k. This is first question. The second one is, if integral of x power 26 x minus 1 power 17 5x minus 3 dx is equal to x power 27 x minus 1 power 18 by k plus c, then find k. And next one is fx is equal to integral 0 to x ln 1 plus t square dt. You have to find f double dash 0. Last question is this one. Fx is equal to x cube plus x plus 1. Gx is equal to f inverse x. Then equation of tangent to y is equal to gx at x is equal to 3 is. Just write down these questions. Just try these before the next class. We'll do the next class tomorrow. So just try these till then.
Okay.
Have you written them?
Yes.
Okay. So we'll see tomorrow. We'll discuss these four first and then more questions after that. Okay. That's all for now.
Thank you.
Bye.